So hello all, my name is Vuorenoja and I come from across the street from OP Financial Group, which is the largest bank and insurance company in Finland. And my topic for today is CDK-based continuous deployment for open source software, and soon you will find out more what that means. Here is my agenda for today. So first I'm going to introduce you myself, my unit and my project, and then we will take a brief look how we are utilizing AWS for our deployment, what kind of infrastructure as code tools we have been using, and then we will take a deep dive to our CDK pipeline. I will also summarize some of my feelings that I have for CDK and CDK pipelines after that. So me, myself, and I, like the previous speaker, I'm a chain or a jack of all trades and master of none. So I like to hustle with many kinds of things, and AWS is one of them. Here you can see my professional timelines. So some of the technologies I have worked with, and some of the, all of the companies I have worked in. And and I ended up in OP at 2019. I started then to research emerging technologies. Back then it was an emerging technologies team, but nowadays I'm a part of OP Lab. And all that time I have been researching decentralized identity and self-sovereign identity in the same project. The technologies I've been using today, like currently, are Go, AWS, GitHub tooling, and a little bit of TypeScript and iOS stuff as well. So OP Lab is the innovation unit of OP Financial Group. We have around 30 people. We have offices at Helsinki and Oulu, but actually I live in Tampere, so remote working is also possible. We have various tasks from strategy work to the company-wide innovation acceleration. So basically we help the business units to do experimentation with different kind of technologies and business. Also, we have been self-sovereign identity experts since 2018. So we have been doing this kind of pioneering research on that topic, and this is what I'm involved in. So what is self-sovereign identity? Just a brief overview. It's a new way of handling identity data. So the idea is that entities such as we individuals, organizations, or even things becomes the owners of their own data. It's basically based on public-private key cryptography. There are some more advanced cryptographies used there as well, but basically the idea is that on the public-private key stuff. It's a worldwide movement, so we are seeing constantly new startups, new open source projects coming up and starting to solve problems around this field. We have also national network plans in many countries. So in Finland we have the FindiNet cooperative, which is this kind of common public-private sector effort to build this kind of FindiNet network that different organizations can then utilize to build these applications that utilize this decentralized identity, the new way of handling this identity data. And last but not least, we have the Findi agency, that is the open source project that we are working on at OP Lab. Coincidentally, it has the same name as the FindiNet, but it doesn't have a direct relation to the FindiNet, so it could be like OP agency as well. So at some point we realized that, okay, we have been producing quite a lot of code and quite a lot of stuff around this stuff, and maybe somebody else could benefit from it as well. So we decided to open source our codes a couple of years back, so you can find it all in GitHub. So verifiable credentials is the core of this technology, and just the brief overview is that we have these different entities that can exchange data. So issuers can issue holders credentials, and verifiers can then prove these credentials without the holder revealing the whole of the credential to the verifier. So let's say police is an issuer, it will issue you a driver's license, you will get it into a digital wallet, and you can then present a proof to another party of that of that driver's license, the verifier can verify that, okay, this is a valid driver's license without having a direct integration to the issuer. So that's the beauty of this technology. So when we started to work with these things, like 4 years back, we had this Python script that demonstrated this whole thing for us. It was written by the academia, and well, something was missing, we realized. So the cryptos were working quite well, but there was no communication pipelines built like between these parties. So actually what we needed to build was this. So we needed to do end-to-end encrypted communication pipes between these different parties, write complex asynchronous protocols that handle the exchange of this credential data, do the access to the decentralized resources from different kind of devices, and of course the usual web service stuff. So there was a handful. And this is what we come up with. So this is the open source project that we have published. It is a platform that different application developers can utilize to use these credential services. So it does all the heavy lifting related to the credentials, the cryptos, the asynchronous communication for the application, and the application can just use the APIs to handle the wallets and the credentials and the stuff. It has a microservice backend, so the backend services are written in Go, and then we have also this React static front-end application. Yeah. So already at the start, we realized that we need to have this kind of cloud environment where we can easily run different kind of demos and proof of concepts on top of this platform, so that we don't always have to ramp it up again and again. We have a really small team, so currently there are only 2 of us, so 1 in addition to me. So we don't want to waste any time to like manual deployments or fixing regression. So we have been starting to build this automation like early on from the start. And why we chose AWS was that, okay, that's the de facto public cloud at OP, and therefore it's really easy to start working with AWS OP. Also, when we started to do this like 4 years back, I was interested in gaining more experience using AWS services, and especially the native tools like the Elastic Container Service. So that is why we started to build this stuff in ECS. Nowadays, I probably would choose something more platform agnostic like Kubernetes or so. But in any case, it's a very delicious project with many delicious problems. So it's fun to deploy this kind of stuff to the cloud. We have the 3 microservices running in the ECS, and then the load balancer is redirecting the both gRPC API requests there and also the HTTP requests coming from the CloudFront. And then the static web wallet application is deployed to S3, and it's deployed via CloudFront. And also we use GitHub tooling quite heavily because, as you probably know, GitHub is free for open source projects. So for instance, GitHub Actions is something we use for all of our testing. So basically, whenever we do a release, we can be quite sure that, okay, it already works when we are moving the stuff to AWS. So all of the testing is done in GitHub Actions. We also use these GitHub packages for hosting the container images, so we don't use the ECR for that. This way it's also like easier to share the container images to anyone who is interested in using of them. Okay, but let's start with the infrastructure as code tooling. So when I started to work with this project, I had been using Terraform in some of my earlier projects, and for me, it felt always like a bit of a compromise to use Terraform, as it's a third-party tool, and there is like some bits and pieces missing here and there. So I tried to do an experiment and take also the native approach in this IAC tooling stuff. And well, the only option back then was to start writing these CloudFormation templates. So you probably know that the CloudFormation is the AWS service that allows you to provision your infrastructure with JSON or YAML formatted templates. And the infrastructure is organized as stacks. So all of the resources you define in a single stack are created at once and then removed at once. So it's really handy when you can create and delete a lot of resources at once. You can manage the stacks through the AWS CLI or the CloudFormation UI. So basically, when I started to write these definitions, it was about writing a lot of YAML, deploying the stack to the cloud with this AWS CLI, and retrying. So banging my head against the wall many times. And there was a lot of manual work. I didn't manage to do it all. Like I didn't manage to define all the needed stuff with these templates, and I needed to write a lot of custom scripts. So then AWS released the CDK, and this was like the second phase. The idea of the CDK is that you can write these CloudFormation templates using programming languages. So the CDK tooling, takes this, so like this code snippet written in TypeScript, it takes that and compiles it to the CloudFormation template. And it felt, for me, it felt a bit weird. Why would I use this kind of dynamic language to define these static resources? But I gave it a try, and actually I haven't missed writing YAML after that. So the best thing about CDK is that you have access to these resources that are defined in a more higher level. So they combine these different AWS services so that you don't have to know each dirty detail of each AWS resource. So they speed up your work a lot. You can also customize, reuse, and share these definitions far more easily than with the YAML stuff. And of course, I can use all the familiar tooling for that I use with other TypeScript stuff. So I can use VS Code, my favorite IDE, and have the code completion available. I can use NPM for package managing. I can even write unit tests for this stuff, which is mind-blowing and weird, but yeah, I do it. And yes, and then I can also do the versioning in the similar style as with other Node projects. So this was quite nice experience for me, and I even wrote this pipeline with the CDK stuff. So the pipeline that makes the updates to the infra. But my target initially was that any person could easily take these scripts and like put this agency running in the AWS without any external help, and still there was many custom steps in the setup, and it felt for me like a little error prone. So I wasn't completely happy with it. Also, I didn't like the model where I was like executing these templates from my local laptop. So I would have wanted to have a model where the pipeline creates the resources for me. So I don't have any hidden states like in my laptop that I used in the process, but I can be sure that, okay, everything that is needed for the deployment are in the cloud and available to the pipeline. But it then came CDK version 2. And actually what happened was that I started a course in OP Software Academy to study about CDK. So I wanted to validate my learnings that I had done before, like on my own. And it introduced me to this concept of CDK pipelines. And the idea is that the developer creates only the pipeline in her own computer, and from that moment on, the pipeline handles all of the deployment and all of the updates to the deployment and updates to the pipeline. So this was actually the missing piece for me. Yeah. So more about CDK pipelines. So it's yet another abstraction on top of AWS services, but this time for the code deployment, like the continuous deployment and integration services. So underneath it uses all of these AWS services. It just like tries to combine these stuff nicely for the CDK application developer. So it utilizes AWS code pipeline to build, test, and deploy a new version. Like said, it's self-updating. So it means that the pipeline is deployed only once from the developer desktop, and after that, all changes are done through the version control. So that, for instance, that eases up when multiple developers are working on the same project. So one just creates the pipeline, and then everybody can do the changes to the pipeline using the version control. Then it supports out of the box multiple accounts and regions. So you can use the same application to deploy to several targets. So for instance, you can have different accounts for development, testing, and production environments, and you can use the same pipeline to deploy to them all. I haven't actually been using that a lot, but it sounds like a really useful feature. And last, it's heavily opinionated. So they state in the documentation that it's CDK way or the highway, and this is something that you just need to accept if you are starting to use these CDK pipelines. Okay, but let's dive into our pipeline. So first, about how to set up the agency to the cloud. So we have this single TypeScript CDK application that sets up all the needed agency services, and the code is residing in that Findi agent infra repository. A more proper way would be to do this so that perhaps each and every one of the services had an own pipeline, an own CDK application for the updates, so that you could make changes to a single microservice. Now the model is such that you whenever we are updating the deployment, everything is deployed. So if I would do this in like a production kind of setting, I would probably refactor this somewhat, but in this phase, it's good for me that I'm able to create all of the resources in one stack and delete them at once. So I have been this model has been working for me in this phase. Like said, it's open source, so you can go and check it out if you want to. So there are some prerequisites that are not like automated. So of course you need to have the proper tooling to set up the pipeline. Then you need an AWS GitHub CodeStar connection for fetching the sources from GitHub. So that's not needs to be done through the console manually. Then you have to have this AWS Route 353 hosted zone so that the deployment can set up the needed domain records and TLS certs. And then, of course, you need the agency configuration, so all the settings you need for the product itself. And what happens in the setup, we store some values, so basically the agency configuration to the parameter store as well to the secrets manager, so that they are available for the pipeline when it does the deployment. There is also some custom step in this setup phase that's like me not acting in the CDK way, because if you have used CDK, you know this context file. So CDK has this concept of context where it stores things like your AWS account ID or your domain name or some information about the availability zones and so forth. So what CDK is recommending that I should store this file to the version control. Well, this is something that I don't want to do because the version control is open source, and I don't want the world to know my AWS account ID. So what is happening actually in this setup phase is that the developer needs to make the first synthing in her local desktop. So synthing means the compiling the code to the CloudFormation template definition, and that will produce you the context file, and then that is also stored in the parameter store where the pipeline can access it. So that's one way I have been like a little bit hacking the CDK way in this project. Okay, but then you can just say CDK deploy and smoke a lot of cigarettes and fetch some coffee and wait a lot of time and then navigate to the AWS console. There are two views that interest you after that. So first, you will have a new pipeline in the code pipeline sections. So probably when you first run it, it will say failed. But here is all well because everything has succeeded. So we will take a peek what's happening in that pipeline next. But that's the one view, and the other view is this CloudFormation UI, where you see your stacks that the pipeline has created for you. So you will have two new stacks there. So there will be this pipeline stack, and there will be this infra stack. And yes, this events tab will become very dear to you, because when you have this failure text, you should probably use this events tab to find out what went wrong. Okay, but let's dive into the pipeline itself. So these are always the stages that the CDK pipeline contains. So there is the source, build, update, pipeline, create assets, and deploy stage. Some of these stages are created by the CDK pipeline for you like automatically, and you cannot edit them. And some you can like define the content that what is happening in those. So the first stage is the source stage, and this actually is when you are defining where to fetch your sources. The pipeline will analyze your CDK application and fetch all the sources in this stage. So actually we have now 5 different repositories that will trigger this pipeline. So we have the 3 microservices, the front-end application, and the CDK application. And actually we don't use the code for them except for the front-end. We are building the front-end in this pipeline, and the CDK application, of course. But for the backend services, we just use them as this pipeline source to get the triggers. So whenever we do a release, we push stuff to the master branch, and that will trigger this pipeline. So any of these 5 repositories, if we do some changes to the master, this pipeline is run. Then there's the build stage. So this is the stage where code is compiled to the cloud formation template. So output of this stage should be the cloud formation stuff that's understood by the CDK tooling. And I think there has some default step here. I'm not sure, but anyways, I have overridden this synth step here because I have some custom functionality that's especially related to this storing of this context stuff. So here you see the context manipulation. So it's fetched from the parameter store, the context. I also do some preparing for the front-end build environment. So because actually what also happens in this build stage is that my front-end code is built. So when I'm defining the front-end, I will say that, hey, okay, I want this bucket to contain files that you can build with this magic. So, and then the CDK can analyze that front-end code and sees that, okay, I need to build these kind of files, and that is what is happening in this phase. These are called the assets. So in CDK context, assets are either files in S3 buckets or the Docker images that are built in this build stage. Okay, then the next stage is update pipeline. So we cannot do any changes here. So this stage will modify the pipeline with new stages and assets if necessary. So actually what's happening when the pipeline is run, like the previous build step, it always runs it with the previous version that you have stored into the pipeline. So if you do like any changes to this synthing stuff here, it's always run first with the old stuff, and then when it proceeds to this update pipeline stage, then it will modify the pipeline and it will be rerun again. So it's kind of confusing at times when you see that, okay, why is this cancelled or failed or something, and it's restarted. But it's due to this, that you have some changes done in the pipeline and it has to like rerun it with the new definition. Then the asset stage will publish you those assets that I mentioned just now. So this source bundle stuff I define in the front end stack, and here I say that, okay, do this magic that you can build my React application, and then I copy the output to the asset output folder, and then the CDK can like do that in the build stage, and in this asset stage it will publish the stuff so that the deployment can then like fetch the correct files for the deployment. We don't use any ECR images because we have these GitHub packages in use. And then the final stage is the deploy stage. So these two, I'm not sure what's happening in the prepare stage, but the deploy actually is the stage when the pipeline creates the deployment for you. So this stage creates the S3 buckets for me and the load balancers for me and the ECS tasks and so forth. So this will usually in the first run take a while and most probably fail. And then I have some custom steps, so you can define also like these post-deployment custom steps here. So we have actually a step for updating the backend service with the CLI, because there are some missing features in the CDK with the ECS service type we are using. So I need to use CLI for updating the service, not to like lose some settings. So that's kind of one dirty hack also. And then we have a configuration step where we onboard an admin user, and then we do some end-to-end testing like the last. So just to confirm that, okay, the deployment went well. But there are like countless custom steps that you can also configure here. Okay, so that was basically the content of our CDK pipeline. Then about my feelings. Yeah, so let's start with the yikes. This first bullet is something that I like strongly feel about AWS in general, not only with the CDK. So sometimes just retrying things work. So that's something that I just really hate, that there's no determinism. And usually I don't have the time or energy to find out that what was this reason that when I retry things, it just works. Also, this debugging stuff is sometimes really challenging. So I mentioned the CloudFormation events tab. When I have things like request failed 400 there, and I just copy that text and go to Stack Overflow to find out what is happening. Is that like a proper way to like use a service that I give money for? Why can't there be like good error messages? That's really hard for me to figure out. Then I think that the CDK documentation is still like quite incomplete. They state that they support only the CDK way, but for me it's still unclear what that is. So well, obviously it's not the open source way, because they are recommending to store the context file to the repository, and I think that's a bit of unprofessional, because you don't want to ever put your context data in the repository. But like these asset stuff, when I worked for the first time with it like a year ago, there was no documentation related to these assets. Now there is a little, and even some blog posts like from external people to describe how to use them. But I think that if they want this to fly, they would need to make like complete example applications. Then there's this thing that lack of transparency in general. So there are a lot of secret things happening under the hood with a bit of extra cost. So the CDK is creating for you these ECR registries and these CloudWatch logs and these S3 buckets and storing these assets here and there. And you have no way to define a lifecycle policy for them by default. Of course, you can do it in a custom way, but you should like pay attention there that okay, it may cost you money. But not all so bad. There is also some good things. So CDK is really a nice friend after the YAML stuff. So I really like writing, sharing, and testing these definitions with the CDK tooling. And we actually do unit testing for these definitions. So we have these snapshots stored in the repository control, and the testing compare the test results to the existing snapshots. So for instance, when I update the CDK library in this CDK application project, I get to see what has been changed in the snapshot. So it's easier to monitor changes. And this model where the pipeline creates and updates the deployment, that's actually the model that I like. That the changes are coming through the version control. The state is managed in the pipeline in the cloud. There are no hidden states in my local machine, and there are less custom hacks. I don't need to write so many bash scripts doing this and that and whatnot. But you have to really remember that the parameters that the pipeline needs to be stored in the cloud as well. So that's something you should keep in mind. Yeah, the multiple accounts or region stuff sounds quite cool. I haven't tried it out so much, but if I would have multiple accounts, I would probably check it out. And yeah, it's working. So we are doing deployments at least daily, sometimes even more often, and I'm glad the way it works. It works for our purposes now. Like, we are not running a production service. We are doing this experimentation stuff, and for us it works really well. Of course, with a little bit of highway. So there were these hacks that I mentioned along the way. That's it. Thanks.